Same thing in polar. So I've got intersection points and labels. I know about r is 1. So to do polar, what do I start with?
Double integral.
Okay, there's going to be a double integral, and I'm going to be integrating
R,
r, right?
dr d theta.
dr d theta. All that jazz being my d area, right?
Yeah.
Okay. So where do the radii go from?
Looks like 0. Oh,
They go
well,
from
it's 1 unit apart, so 0 to 1,
negative
right? No.
pi over
Still
2 to
running
pi
around.
over 2.
It's not always.
Okay, so if I did 0
I
to
mean,
1,
Theta go negative pi over 2 pi.
the radii going from 0 to 1, and the theta is going from,
Theta would go from 0 to
Wait,
wait, where does the theta start?
Negative pi over 2 to pi over 2.
No, it's like,
Yeah, so theta 0 is right like this, yeah?
yeah.
So I want to go from down here to up there, right?
Oh,
So I want to go from minus pi over 2 to pi over 2.
okay.
You guys all buying this?
I don't know about the radius
Something
though.
different for our radius.
Good, the radius is totally out. So what I have here right now
Last time.
doesn't take into account what?
The change as it goes.
Yeah, so what I have right here is this half of the right circle. You guys all see that? Didn't take into account the other circle at all, right?
Yeah.
Okay, so my radius is totally dork.
Okay.
So I need to do something better with the radius. What's,
Well, x squared plus y squared equals r squared, right?
yep.
And so you set both of them.
Well, R is equal to 1.
No.
Okay,
You get
How about let's just look at the equation for that second thing, right?
yeah.
I want to make the substitution x squared plus y squared is r squared, right?
Okay.
close.
Okay. This is close, yeah? So what do I need to do to get an x squared plus a y squared?
Finish up the x minus 1 extended out, and
Foil?
then put everything that you don't need onto the other side.
Okay, so I got x squared minus 2x plus 1 plus y squared is 1, right?
And then
That
put the
just-
Okay, so x squared, y squared, that's r squared. Then there's a minus 2, what the heck is x?
R
X is R cosine theta.
R cosine theta.
Okay.
And then there's a,
Plus,
cancel the 1s so you get 0. You guys see that?
yeah. Could you
Solve
factor?
for R in terms of theta.
Solve for r in terms of theta, good. You guys see that? So, if I factor, wait, how do you solve for r in terms of theta?
Well, you could factor out an R.
Well, we can flip it
doesn't
and do
help
theta
the
in terms of
use
R.
with the theta.
How about this? Let's factor an r out. So we got r times r minus 2 cosine theta equals 0. Is the radius 0? No.
No.
So let me drop that piece. So that looks like r is 2 cosine theta to me.
Okay.
Cool?
So then it would just be from 0 to 2 cosine theta.
Okay. So
we
if I
can- we
do
can-
from 0 to 2 cosine theta,
Now you're not taking into account the other
yeah, now I'm not taking into account the first circle.
circle, yeah.
Oh.
You guys see that?
So now we have to replace 0 with the other circles.
So then,
Okay, so right now this is running.
wait, the other circle, it's R equals 1.
So it'd be 1 to 2 cosine theta.
Yeah?
I'm so lost. I think.
Okay.
Yes, it would be.
Super lost?
Not super, but like.
Okay. Let me make a little more space and let's redraw our picture. You guys remember the thing for that circle, right?
Yes.
Okay, so I got a circle, another circle, and this one is r equals 2 cosine theta, right? And this one over here is r equals 1.
And their unit.
And my
one.
radii start here.
Okay.
So this is 1. Here's a radius. You guys all see that?
Wait, then that means 2 cosine.
We're gonna
It'd be-
have to split the integral.
Yeah. That's the problem. I've been trying to do this as one integral, right?
Yeah.
But the radii aren't consistent.
Okay.
When I'm in some of the angles, right, they hit the first circle, and then when I get to a kind of critical number, right, it flips to hitting the other circle.
So should we do R last then? Or
I just need to do r in 2 pieces.
Which means you're just gonna.
Yeah, we can't really do.
So in polar, I
Straight up
can't really
first.
do this.
You're gonna have to do a plus another double integral.
Yeah, so let's write them down. So in polar, I'll need the double integral of r dr d theta plus the double integral of r dr d theta.
Well, pi over 2, negative pi over 2, pi over 2 will be the same in both of them, wouldn't it?
That's
So
the
it'd
problem.
Be 0 to 2 cosine theta, and then 2 cosine theta to 1.
Okay, yeah, so I need 0 to this guy. Okay, see that?
That'd be the.
So
not-
some of the time, right, I need to go, my radii I need to vary from 0 to 1.
That'd just be 0. Yeah.
And some of the time, I need to vary my angle from 0 to 2 cosine of theta. Sorry, I absolutely have to turn the camera around. You guys are super quiet.
Or they just don't care.
Or they just don't care. All right. So, where do the thetas go?
what are these stupid humans
On
doing?
the 0 to 1, the thetas are different.
0 to 1.
Okay, so I just need to know what the theta is, right?
Mm-hmm.
That puts my radius right there. You guys see that?
So we have
Oh, that's.
whatever three
If you just
root
make
3
a
over 2
right
over
angle.
a half is.
That was 1/2 comma square root of 3 over 2, right?
Mm-hmm.
Isn't that a 60 degree?
Yeah, it looks like 6.
Alternatively, right? That's when radius is 1 hits 2 cosine theta. So that's when 1 equals 2 cosine theta.
So, oh yeah, it becomes 1/2.
That tells you
Equals cosine.
Cosine.
cosine theta is a half,
Yeah.
which tells you you're looking at
Looking at a 60 degree.
60 degrees. So on
On
which one?
0 to
0 to 1.
On the 0 to 1, I want to go from,
0 to pi over 2. Pi over.
I'm definitely with the pi over 3, but you want to go from,
Oh, the symmetrical one. So negative pi over 2.
yeah, I wanted to go from negative pi over 3.
I moved.
Bye, dear. So I want to go from negative pi over 3 to pi over 3 on the 0 to 1 circle. And then on the other circle, I want to go from 0 to 2 cosine of theta on the radius.
Well,
And the thetas need to go from,
0
not from 0.
not from 0.
to, or no, it's
Right, it starts here.
pi over 2 to pi over 3,
So that's pi over 3. I want to go from pi over 3
pi
to
over 2.
pi over
And
2.
then symmetry, multiply it all by 2.
Perfect. Pi over 3 to pi over 2, and I need 2 of them. So the thing that's happening here is that there's a blue piece and a blue piece
And then the pi over 2 comes.
and kind of a red bit, right?
And that's just straight.
This is the red bit, and the other one is the 2 blue bits, right? Does that kind of make sense?
Sort of.
So is this easier or in polar?
No.
You'll get numbers easier.
Yeah.
Yeah, it's a trade-off, right? Just like everything. If you do it in Cartesian, right, you have an easy to write down integral, and you pay for it by having to do a trig subproblem. If you do it in polar, right, you have an easy to write down, or easy to execute integral, but you have to spend some time figuring out angles and write it down in the right way. Cool? So hard to write down integral, easy execution versus easy to write down, hard execution.
I think easy execution means easier arithmetic.
Yeah, and the thing that we're traditionally worst at is arithmetic. So
Is that a pi over 2 over there, or?
yeah, it's a pi over 2.
Okay.
And that's because I'm going from this 60-degree angle till it hits vertical. And that's really because the tangent line to that circle is vertical there.
I was just making sure. It was very flat.